Okay, let's look in this next practical activity at endothermic versus exothermic reactions. Endothermic reactions need to take energy from their surroundings in order to drive the reaction, in order to make it happen. So that means that the environment around an endothermic reaction usually becomes cooler, feels colder. And the opposite is true of an exothermic reaction. The vast majority of chemical reactions are exothermic, which means they release heat to their surroundings. So as a result of the chemical reaction, things begin to feel hotter. The activity that you're going to undertake is fairly simple in terms of its method, but it's very, very important that you pay careful attention to the white powders that you're using. It's very easy to confuse them. So you need to pay careful attention for safety reasons, and I'll draw your attention to that when we get to it. First of all, your aim is to demonstrate the temperature changes in endothermic reactions versus exothermic ones. The method for your endothermic reaction is this. First, add 12 grams of calcium chloride hexahydrate, and I include the chemical formula so that you might recognize it if that's what's written on the stock bottle. Add that to a beaker. It's important that you identify the calcium chloride hexahydrate and make sure that that's the powder that you're using when you're measuring 12 grams. Separately, measure out 100 milliliters of tap water in a measuring cylinder and record the temperature of this water in the measuring cylinder before you add it to your beaker. Next, pour the water from the measuring cylinder into your beaker and stir well. Please don't stir with the thermometer. That is probably the most common way, aside from being dropped, that thermometers get broken. So we've supplied you with glass stirring rods. Please use the stirring rod until the solid is completely dissolved. Then monitor the temperature of this solution. You want to record the lowest temperature that it reaches. The lowest temperature that it reaches. So you'll need to keep a careful eye on it because you want to keep watching it. No matter how cool it gets, you want to keep watching it until you see it start to warm up again in the other direction. And then the number that you write down is the coldest temperature that you saw. Now the method for your exothermic reaction is very, very similar. And again, this is why you need to be very, very careful to read your labels. First, add 1 gram, only 1 gram, of calcium chloride anhydrous, or anhydrous calcium chloride. Again, I include the chemical formula to help you to recognize it. Add this to a beaker. Just as before, separately in a measuring cylinder, measure out 100 milliliters of tap water and record its temperature before you pour it into your beaker. Again, pour the water into your beaker, stirring well with the stirring rod to prevent the thermometer becoming broken. And then monitor the temperature of this solution to record the highest temperature that it reaches. Once again, you're going to need to keep a careful eye. You're going to watch the thermometer until the temperature begins to cool again. And that way you'll be able to write down the highest temperature, the highest number that you saw. Now, risk assessment. I'm going to harp on this one because it's important. Both powders are very irritating to the eyes, but much more significantly, if you confuse the two powders, in one case, your water will very quickly exceed the boiling temperature of water. And that will cause it to splash back towards you quite quickly and suddenly. And that can cause burns. It can also potentially cause eye damage, of course, if it's splashing into your face. So it's important, I say again, that you wear safety glasses at all times. Also, in this case, I'm going to ask you to wear an apron. because if it were, God forbid, to splash back onto you, I'd like you to have an apron to absorb some of that heat. You need to read the labels in this practical activity very, very carefully. And if you're feeling insecure or uncertain, you need to ask me for assistance before you add water to anything, so that we can be sure that nobody suffers any burns. As for safe disposal, everything here can be flushed down the sink when you're finished with it. And I'd like you, before you come into the lab, to copy down this results table. It might also be helpful to copy down that note that I've given you to help you understand how to calculate the change in the temperature. And that's what I need you to do tonight, ready to go, so that you can participate in our practical activity tomorrow.